A review of atoms and elements, part 3.
In this session, we're going to be looking at reaction stoichiometry, advanced conversions, and some examples, and even more examples. Reaction stoichiometry is basically the process of converting from moles of one substance to moles of another. What you need to do this is a correctly written and balanced chemical equation. So if you still do not know your polyatomics, you do not know how to write a formula, you're worried about your knowledge of writing a chemical equation, well then, frankly, friend, you need to go back. You need to go back and make sure that you know how to do these things before you start watching this particular tutorial. I'm going to trust that you know how to do this. So let's move on. Potassium chlorate decomposes to produce potassium chloride and oxygen. Let's start with potassium chlorate. Potassium is K, it has a charge of +1. Chlorate is ClO3 minus 1, and when I write the formula here, I'm going to have KClO3. Decomposes, that means one reactant, more than one product, so an arrow, to produce potassium chloride. We know that that's going to be KCl, and oxygen plus O2. So I look at this and I say, hey, I'm pretty comfortable with this as an equation. Now I need to balance it. 1K, 1K, 1Cl, 1Cl, 3 oxygens, 2 oxygens. The lowest number that both of these will divide into is 6. So I'm going to put a 3 here. I'm going to put a 2 here. So 2 times 3, that gives me 6 oxygens here. 3 times 2, 6 oxygens here. But now I have 2 Ks, so I need a 2 in front of here, 2 Ks, and that 2 will distribute through, so I'll have 2 chlorines, and my equation is balanced. Awesome. Now I can move on to what I really need to do. Answer this problem. What is the total number of moles of potassium chlorate needed to produce 6 moles of oxygen? So my given is 6 moles of oxygen. I need to convert this into moles of potassium chlorate. So my units for the bottom of my conversion are going to be moles of O2. What I want is moles of KClO3. Now, where do I get these numbers? I get these numbers from the coefficients from my balanced equation. So I'm going to take the 3 in front of the O2 and put it on the bottom. I'm going to take the 2 in front of the KClO3 and put it on top. Moles of O2 cancels moles of O2. 6 times 2 is 12. Divided by 3 is 4. My final answer here is 4 moles of KClO3. No gram formula masses, but what I do need is a correctly written and balanced chemical equation. Nitrogen reacts with hydrogen to produce ammonia. So nitrogen is N2, reacts with, that's a plus sign, hydrogen is H2, arrow, ammonia. Remember, ammonia is NH3, not NH4 plus 1. That's ammonium. That's a polyatomic ion. We want ammonia. So now I have a correctly written chemical equation. Now I need to balance it. 2 nitrogens, 2 nitrogens. That is balanced. 2 times 3, that gives me 6 hydrogens. So I need this to be 6 hydrogens, so I'm going to put a 3 over here. My equation is now balanced. What is the total number of moles of NH3 produced when 10 moles of H2 react completely with N2? 10 moles of H2. So I'm going to take that 10 moles of H2, which is my only given, multiplication sign and a line, moles of H2 on the bottom. I want the total number of moles of NH3 on top. So again, I'm going to go to my balanced equation. I'm going to look at the coefficient in front of the H2. That's a 3. I'm going to look at the coefficient in front of the NH3. That's a 2. The 2 will go here. Moles of H2 cancels moles of H2. I'm left with moles of NH3, which is what I want. So 10 times 2 divided by 3 gives me 6.7 moles of NH3. And when I look at this number for 10, it has a decimal on the end, which means I need to take my answer to two significant figures, which I have done. So my final answer is 6.7 moles of ammonia. Translate the chemical word equation to formula equation. Aluminum metal combines with oxygen gas to produce aluminum oxide. Okay, aluminum metal, Al, combines with plus oxygen gas, O2, to produce, arrow, aluminum oxide. I'm going to take a moment. I'm going to say, all right, aluminum is +3, oxygen is -2. I'm going to cross that down. That's going to be Al2O3. I know I have written the right equation. And people, it is so worth taking the time to make sure that you have the right formula here before you try to balance it and before you try to move on. I can't stress that enough. All right, now I need to balance this thing. I could throw a 2 in front of the Al, but I need to deal with these oxygens. I have 2 oxygens on the reactant side, 3 oxygens on the product side. I've got to balance those, so I'm going to put a 3 here to get 6, a 2 here. 2 times 3 gives me 6. 2 times 2 gives me 4, so I need to put a 4 in front of there. All right, I've got a balanced equation. This is advanced conversions because we're not just doing a mole to mole problem. We're taking it much farther than that. So what is the minimum number of grams of solid aluminum required to produce 74 grams of aluminum oxide? This is a multiple step conversion, and I would highly suggest doing this in pencil if you're working on paper, and take your time. So we're going to start with 74 grams of aluminum oxide, Al2O3. Now, AP Chem mantra, convert to moles. I can't just throw the coefficients in this ratio because those coefficients refer to moles. So I need to get from grams of aluminum oxide into moles of aluminum oxide. So 1 mole of Al2O3. I will tell you that the gram formula mass of Al2O3 is 102 grams of Al2O3. Great, now I'm in moles of Al2O3. Multiplication sign and a line. But I don't want moles of Al2O3. I want moles of aluminum. So again, I'm going to take my units from the top and put them on the bottom so they can cancel out. Moles of Al2O3. I want moles of aluminum. This is the point right here. This is the point when I'm going from moles of one thing to moles of another that I'm going to go back to my balanced equation. So the coefficient in front of Al2O3 is 2. The coefficient in front of Al is 4. So I'm going to put those there, and that is key. Now again, I can't stop here because I don't want moles of aluminum. I want mass of aluminum. So I'm going to take it one step farther and say 1 mole of aluminum is equal to the atomic mass of aluminum, which is 27 grams of aluminum. Now, again, before I do all my math, I'm going to take a moment and make sure that my units cancel. Grams cancel grams. Moles of Al2O3 cancels moles of Al2O3. Moles of aluminum cancel moles of aluminum. I'm left with mass of aluminum, which is what I want at the end. So when I do all the math, 74 times 1 times 4 times 27 divided by 102 times 2, my final answer here will be 39 grams of aluminum. This process is not difficult if you take your time and you have a plan of how you're going to do it. So, I cannot stress this enough. Have a plan. Let's do another example. Ammonia is combined with oxygen to produce nitrogen monoxide and water. Okay, ammonia, NH3, combined with oxygen, that's going to be O2, to produce, that's an arrow, nitrogen monoxide, that formula is NO, and water, plus H2O. All right, I need to balance this thing. 1 nitrogen, 3 hydrogens, 2 hydrogens. So let's just start off by doing that and see what happens. So I'd put a 2 here, and I'd put a 3 here. So that would now give me 2 nitrogens. I'm going to put a 2 over here, and then I'm going to look at my number of oxygens, because the nitrogens are balanced, the hydrogens are balanced, the oxygens are all over the place. So when I look at my product side, I have 2 oxygens here, 3 oxygens here, and that's a total of 5. I don't want 5 because I have no whole number times 2 that's going to give me 5. So I need to stop and reset, and what I'm going to do now is double everything. I had a 2 in front of the NH3, so now I'm going to make that a 4. And I had a 2 in front of the NO, so now I'm going to make that also 4. And I had a 3 in front of the H2O, so I'm going to make that 6. I've basically doubled everything. So now when I look at this, I can say 4 nitrogens, and then how many hydrogens? 4 times 3, that's 12 hydrogens, and oh look, 6 times 2, that's 12 hydrogens. So now I'm going to look at my number of oxygens. Well, I have 4 oxygens here, and I have 6 oxygens here, and 4 plus 6 is going to give me 10, and that'll work for me. So I can do 5 times 2, and that's going to give me 10 oxygens. So now I have finally worked through this, and I have a correctly written and balanced equation. What is the maximum number of molecules of nitrogen monoxide that can be produced when 3.2 times 10 to the 22nd molecules of ammonia are completely reacted? All right, so I'm given a number of molecules. 3.2 times 10 to the 22nd molecules of ammonia. I've got to convert this into moles. So 1 mole of ammonia is equal to 6.02 times 10 to the 23rd. We're referring back to that. Now I'm in moles of ammonia. So I'm going to do moles of ammonia. And what do I want here? I want nitrogen monoxide, because ultimately I want molecules of nitrogen monoxide. But I need to get it to moles of nitrogen monoxide first, because that is my base unit. So this, again, this step right here is where I go up to my coefficients. The coefficient in front of NO is 4. The coefficient in front of NH3 is 4. So now I'm in moles of nitrogen monoxide. The last step is to get me into molecules of nitrogen monoxide. So I know in 1 mole of nitrogen monoxide, I have 6.02 times 10 to the 23rd molecules of nitrogen monoxide. So now I need to make sure that my units cancel. So molecules cancel molecules, if I'd written it down there. Moles of NH3 cancels moles of NH3. Moles of NO cancel moles of NO. And I am left with molecules of NO. But now even something more interesting happens. Turns out that I can look at this and say, well, my Avogadro's numbers is going to cancel. And the 4 and the 4 are going to cancel. So what do I have? Well, I have what I started with, which is 3.2 times 10 to the 22nd molecules of NO. Now, is there a faster way of doing this? Of course, you could have looked at this and said there's a faster way of doing it. There's always a shortcut. But when in doubt, do the work. Show what you know. That is what is key when you are solving these problems. Let's look at another example. Given the reaction, 2 KClO3 yields 2 KCl plus 3 O2. What is the total number of grams of KClO3 needed to produce 120 grams of O2? All right, so we have a mass to start with, 120 grams of O2. And again, the first thing that we're always going to do is take our mass and convert it into moles. So 32 grams of O2 is our mass, 1 mole of O2 on top. Then we can get to the step where we can use the balanced equation to convert from moles of O2 to moles of KClO3. I cannot stress again how important it is to realize you have to go from mass to moles in order to get from one substance to another based on this balanced equation. Then I'm going to look at the coefficients from my balanced equation to fill in this ratio. There is a 3 in front of the O2. 3 goes here. There is a 2 in front of the KClO3, so I put my 2 there. And now I am in moles of KClO3, but I do not want moles of KClO3. I want the mass of KClO3. So I'm going to say 1 mole of KClO3 is equal to the gram formula mass of KClO3, which I will tell you is 123 grams of KClO3, equal sign, and then I'm going to go through and I'm going to cancel my units. Grams of O2, grams of O2, moles of O2, moles of O2, moles of KClO3, moles of KClO3, and I am left with mass of KClO3. So my conversion is set up correctly, and I can move on to actually doing the calculation. 120 times 1 times 2 times 123 divided by 32 times 3 times 1, and that will give me a mass of 307.5 grams of KClO3. And since I'm only to 3 significant figures, that really should be 308 grams of KClO3. So this is an example of a mass-to-mass problem. I start with the mass of one thing, I'm going to the mass of another. I need to use that conversion in the middle to convert from moles of one substance to moles of another substance. Let's look at another example. Given the reaction, sodium hydroxide reacts with sulfuric acid to produce sodium sulfate in water. All right, we should know that sodium hydroxide is NaOH. Reacts with sulfuric acid. You should know this acid by now. It is H2SO4 to produce sodium sulfate. We know that sodium is Na+1. Sulfate is SO4 minus 2. I'm going to cross those down, so my correct formula will be Na2SO4 and water. So I have correctly written my equation. Now I need to go back and balance it. So I have 2 sodiums here, so I'm going to throw a 2 over here. So 2, those balance. And then the SO4 I'm going to look at and say that's pretty much going to stay together. Then I'm going to look at my hydrogens. I have 2 hydrogens here, and I have 2 hydrogens here for a total on the reactant side of 4 hydrogens. So if I put a 2 in front of here, 2 times 2, that'll give me 4 hydrogens. And then finally, if I look at this oxygen right here, 2 oxygens here, 2 oxygens here. This thing is balanced because, again, I kept the SO4 together because I had that opportunity to do so. So I have my correctly written and balanced equation. I can go on to the problem. What is the total number of formula units of sodium hydroxide needed to react completely with 125 grams of sulfuric acid? All right, I have 125 grams of H2SO4. Convert to moles. Multiplication sign and a line. I will tell you that the gram formula mass of sulfuric acid is 98 grams of H2SO4. That is equal to 1 mole of H2SO4. Multiplication sign and a line. This is the place right here where I will use my balanced equation because I need to have moles of H2SO4 on the bottom. I want moles of sodium hydroxide because that is what I'm looking for. I'm going to go up to my balanced equation. I'm going to see that there is a 2 in front of the sodium hydroxide. That'll be 2. There is an assumed 1 in front of the acid, so I'm going to put a 1 down here, and then I'm going to continue on. Now I'm in moles of sodium hydroxide, so I need to get out of moles of sodium hydroxide, and I need to get into formula units of sodium hydroxide. And I know that formula units, like atoms, like ions, like any type of particle, is going to refer to 6.02 times 10 to the 23rd formula unit. So when I work this out, I can go through and cancel my units. Grams cancel grams, moles cancel moles, moles cancel moles. I'm left in formula units, which is what I want. So if I work this out, I should get 1.54, correct number of significant figures, times 10 to the 24th formula units of NaOH as my final product. So this is a situation where we're going from mass to particle. Again, this is all about thinking about the process, having a correctly written, balanced equation, and really being methodical about your work. Last example. Given the reaction, methane burns in air to produce carbon dioxide and water. Methane, of course, is CH4. When it says burns in air, we know that is going to mean oxygen to produce carbon dioxide, CO2, and H2O. One carbon, 4 hydrogens. We need a 2 in front of there. So that gives me 4 hydrogens. That is balanced. I have 2 oxygens here. I have 2 oxygens here. It gives me a total of 4 oxygens, which means I need a 2 in front of here. And my equation is correctly written and balanced. So let's move on. What mass of oxygen is needed to completely react with 1 mole of methane? Now, this problem tends to throw people off because we're used to starting with an atom or an ion or a formula unit or a mass. Here we're just starting with 1 mole. Embrace it. It's okay. So 1 mole of methane. So we don't need to do anything except go to the next step, which is converting from moles of methane to moles of oxygen. We don't have to go back and convert to mass. No, just this is the next step. Moles of one thing to moles of another. We go up and we look at our balanced equation. This is going to be 2. This is going to be 1. We are in moles of oxygen, but we do not want moles of oxygen. We want mass of oxygen. I know that 1 mole of oxygen is equal to 32 grams of oxygen. Go through, cancel units, moles of methane, moles of oxygen. I am left with mass of oxygen, which is what I want. So 1 times 2 times 32 divided by the collective 1 will give me 64 grams of O2. And I'm not going to worry about significant figures here. Let's see. Let's make this 1.0. So 64 grams of oxygen as my final answer. So what did you learn? We just did a lot of reaction stoichiometry. We talked about advanced conversions where we're going from one thing to another through multiple steps. And then we just did a bunch of examples, and more examples. Need more help? Feel free to contact me. Have a great day.